Hey, what's up guys? Jake with Legacy 4x4 here again, and today we're going back to the plasma cutter a little bit to make some improvements and to fix something that I broke on it. So what happened is I accidentally burned up the board on it, I think. It's doing some weird funky stuff with one of the power supplies, and I just need to kind of fix it a little bit. So what I've determined I'm going to do is I'm actually going to completely rewire this. I'm going to clean up a lot of it, and I'm going to make repairs on it easier in the future by spreading out the footprint that the box takes up and making it easier to work on and easier to service system for this. What this means is I'm probably going to end up making a custom enclosure for it. I'm fine with that. It's worth it to me so that I could have this a little more spread out. The point of this video is I realized I didn't do as good of a job when I first made this wiring video for the hardware of it. And so I'm going back, and as well as making the improvements and as well as fixing what I broke, I'm going to try to be a little bit more detailed about why I picked some things that I picked and the way that the wiring looks. Hopefully in this video I'll also have a wiring diagram. Anyways, let's go and get started. I'm out in the garage right now, but I'm going to pull the control box off of the back of the plasma cutter here. I'm going to bring it inside, and we're going to do this inside because there's no reason to do it outside. Alright, so we're back inside now, and y'all can see here that this is what all of the controls for the plasma cutter originally were housed in. This box is 10 inches by 18 inches and it's just a little too small to fit everything in a way that is easy enough to work on and easy to manage. And so when things go wrong, it's kind of a pain in the butt to go in there and fix. So part of what we're doing right now is we're going to put it on this 12-inch by 24-inch piece of plexiglass. And we're going to use that to house all of the electronics and kind of spread out all of this stuff over a wider area. After that, then we'll build it into a custom enclosure and we'll use that on the plasma table to protect all the components. So for now I got to go through and I got to take all these parts out and I'm going to lay them back out again, and then we're going to start to put this thing back together. We're going to be adding 2 optical isolators to help control the passage of voltage in and around this controller, specifically the voltage that goes out towards the plasma cutter to turn on the torch and the voltage that comes into the control box from the plasma cutter that runs the torch height controller. Also, we will be adding a couple of small circuit breakers. The point of these is to hopefully protect from any overload, because I think what happened is I burned up the main mesa board due to a brief overload caused probably by a voltage spike in the plasma cutter. So hopefully between having a circuit breaker as well as having some optical isolators will help solve that problem and prevent a future voltage overload that might burn up a $200 board. And lastly, we do have another mesa board. This mesa board is what's malfunctioning, and I can't really tell why, so we're just going to replace it with a new one. Easy enough. Alright, I'm going to go ahead and tear this box apart and lay out the parts and kind of talk through what comes next. Alright, so I got the box completely taken apart and I have all the components sitting on the new piece of plexiglass. I think this is generally how I'm going to lay it out. I might play with it a little bit as we keep going, but this is the general idea. Before I move on, I want to go ahead and cover some of the components of this system and why I picked those components in order to drive this plasma cutter. So we'll start over here. These are the drivers for the motors. So the NEMA motors that I'm using require individual drivers in order to function. The Mesa does not have an internal driver like the hobby CNC board that I used originally, so these are a necessary external component. They do provide a lot more value, and they do provide a lot more control over the way the hobby CNC board was originally configured. For the X and Y motors, I'm using a DM860i stepper driver. These are available from Stepper Motors online. And then for the Z axis, which is a smaller motor, I'm using a DM556T here. Each motor has its own driver, and all of them will be sitting right next to each other over here like this. They do have a heatsink on the bottom of them. They do get a little bit hot, but keeping them together, I've not had any issues with it before, so I'm just going to run it the exact same way on this. By having them sitting like this, I'm allowed to have full access to the individual controls of them, so in the event that I ever have to change anything, I do have the ability to switch it up right there. And then I can get rid of some of the extra steel, because on On the last box, I had to use this little vertical mount that I made here. It's not very complicated, just a piece of angle iron and a piece of flat sheet steel. But now by doing it like this, I should be able to spread it out nice and easy. I'm going to mount the power sources over here the same way I had it previously, using that little mount that I made. Each one of these power sources is also available from OMC Stepper online. They're 115 or a 230 volt power source, and they've got a total output of up to 24 volts. I don't remember the exact wattage output, but the point of this is a 24 volt output, and then it goes up to 4.5 amp output. So when I was doing the research for this, you could choose to use one or two larger power sources in order to power all these components, but these are what OMC Stepper recommends to run these individual drivers and the Meza board itself. So the way this lays out is I pretty much have one power source which runs the Z-axis and runs both of the control boards, and then I have an individual power source that runs each of the individual axes. What this also provides is these provide all the power for the limit switches in accordance with the axes that they're supposed to drive. Moving on, we do have the Meza 7i76E. This is the control board that we're utilizing for this. It's the same one that I used on the last build of this plasma cutter. I just have a new one because I burned that board up. We're using a THC 10AD. This is also from Meza. This is what does the torch height control for this board. We have a standard 5 volt relay here. These are cheap available relays that you can buy on Amazon. These do burn out periodically, and when they do, the torch won't work. These are very cheap though, and so I do just keep a few of these on hand, and whenever they burn out, I just open up the case. It's just easy little 3 prongs, and then you screw in and screw out whatever you need to do. Super simple. For what they do, for their price, they'll work. It is annoying that they blow up though, but it is what it is. Next, we have 2 of these 24 volt optical isolators. Again, these are going to help control the flow of voltage throughout the system so that we don't have any back voltage going towards any of these key components, hopefully to avoid blowing it up again. We've got a couple 4 amp 24 volt circuit breakers. Again, these should help protect some of the key components within the system from having an overload. And then finally, we just have a couple of these little bus bars. I use these to control. That way I'm not running everything into and out of these power supplies. Instead, everything runs through the bus bars to make it a little bit simpler. So the bus bars run like the limit switches and things like that. They get power from the power supply, ran into the bus bar, and then everything ties into this to kind of give it a cleaner install. That's the gist of all the components. I am putting this on a piece of 12" by 24" plexiglass. All the components seem to fit really nicely. So we're going to go ahead and move forward and start installing these things permanently. And then we're going to have to build that enclosure, which is going to have the same panel that like the old one had for the power supply, the fan mounts, and the plugs for the different motors and limit switches. But anyways, with that said, let's go and keep moving. Alright, so you guys can see here I have the entire plexiglass laid out with all of the different components on it. I will say, if I were to do this again, I would have gotten a thicker plexiglass. I did crack this a couple of times while I was doing it, and it also has not quite enough structural integrity to handle the weight of all the components I put onto it. I'm going to remedy this because I don't feel like waiting on another piece of plexiglass to come in the mail. I'm going to remedy this by just simply putting a steel backing on the back of it. I'll just run some steel runners along the outside of it to make a nice sturdy section here. Anyways, let's go and talk through some of the components and how I got them all laid out. On my left, your right over here, I have all of the power supplies. I'm using the same stack system that I used last time. It works well enough. It's not perfect, but it holds them all nice and tight and nice and cleanly over there in the corner. Next to them, I do have the 2 circuit breakers here kind of off to the corner. I figured these don't need to be easily accessible because ideally these don't ever need to be serviced. The only thing that might ever need to happen is just to click down and press on one in the event that there is an overload. Next to them here, I do have the relay. This is in the center of it, easily accessible and easily serviced if it ever does blow. And then next to the relay, I do have the 2 optical isolators as well. Same reason, if they ever blow, they are easily serviced, sitting right where they are. Behind that, I have the new Meza 7i76 board. Again, easily in the center of it, so if I need to service something or move something around or switch a setting on it or something like that, it's going to be easily serviced there. And then next to it, I have the THC AD for the same reason. Off to the far right hand side here, I do have all 4 of the drivers. I've got the 3 big motor drivers and then the final Z motor driver all the way up here at the top. My idea here is now I'm going to run the wiring, and I'm going to try to run the wiring kind of along the sides of this box to give freedom in the center here to manipulate these objects as necessary. Following that, once I get it all wired up, we need to double check the settings on the Meza board. I'll use the previous board to verify those, and I'll talk about what those settings are. After all that's done, we're going to have to make a quick enclosure for this to hold this onto the CNC machine itself. Alright, so starting along with wiring, I'm going to skip the parts about the power. I'm going to get to that in a second. Instead, I'm going to go ahead and start plugging up some of the signal wires for the drivers. So this very back row here on the Meza, the row that is closest to the Ethernet port, that is the row that controls the outputs for the driver signals. You have to make 4 total bundles of wires. They do have the quick connects at the ends of them, and they all use just a simple little flathead screwdriver, so you can pin a bare wire into it nice and simple. When you wire up these wires, they need to be wired in a manner so that you have 4 total signals that need to come from the board. It's going to be pulse positive, pulse negative, direction positive, and direction negative. Those 4 signals are what are going to provide the input to the drivers, which tell the motors which direction to move and how much to move. The direction positive negative obviously provide the direction value for the controller, and then the pulse positive negative provide the total number of moves that the CNC makes. If you're unfamiliar with stepper drivers, the basic idea behind it is for every pulse of output that comes from this board to this driver is 1 period of movement on the stepper motors themselves. You then tune the stepper motors through software to ensure that they move the right distance per the number of pulses that are given. The discussion of that is kind of beyond the scope of this here. I will cover a little bit more about it in the next video when I remake my software video, talking about how you program this board to work with these controllers, to work with the different motors that we're using. I will have at the end of this a full wiring video, but let's go ahead and plug up these 4 little driver input wires, and then we'll move along and we'll start adding in the optical isolator and also the different circuit breakers. I skipped some of the time-lapsey stuff. Let's just go ahead and talk about how we got it set up right now. There's a little bit more wiring that still is yet to be done, but we're going to get into that because I have to have the enclosure built first, because a lot of that wiring is stuff that's built on the external of the enclosure. So now we're going to actually go put this on the dining room table, and then we're going to go outside and we're going to work on building the enclosure and then getting a little bit more fidelity on this project as a whole. Hopefully, once the enclosure is done, it'll go by pretty quickly, and we should just have to do a couple little last minute wiring, and then we can plug it up and test it on the plasma cutter. Let's go ahead and go outside and go work on this enclosure next. Alright, we're outside, and I actually already finished building the box, but I'm shooting this after I finished it because I didn't really know how I wanted to do this moving into it. I kind of just like free-formed it as I went, but it turned out pretty good. I'm happy with the results. I will say that the box is extremely ugly. I ended up making it out of scrap metal, because I only have a half sheet of steel left on the wall that's been untouched, and I'm planning on using that sheet of steel to finish up the interior of the Willys, and I don't want to run to the store to go get any more of it. So I just used a bunch of scrap that I had. So some of the lines don't line up. It's not completely perfect. Truthfully, it's just going to go on the plasma cutter. It's going to get dirty and beat up anyways, so I'm not really that worried about that. We got it all finished though. So the way I did this is I basically just used some 2x2 angle iron to form a bottom tray, and then I framed a box around it as quickly as I could using some 14 gauge sheet metal. Anyways, I'm going to show you guys what this box looks like, and then we can talk about what's coming next. All right, bear with me here. This is a super weird shot, I know, but this is the only way I can really capture the entire case here. I've got to get the camera really high up and kind of shooting down at this, but that's okay. We have the entire case finally completed. So let's go ahead and talk about what this looks like. We'll do a brief overview of the different wiring, and then we'll move on to doing the hardware settings for the Meza, and then we'll install it on the plasma cutter and give it a test, and this video is going to be finished. So to go over the wiring, again, we'll just start over here at the power supplies. We have all four of the power supplies here on the corner. Behind it, we have the red positive distribution block. We have the 2 circuit breakers. Then we have the relay, the 2 optical isolators, the ground distribution block. We have all 4 of the stepper motor drivers. In the middle here, we have the Meza 7i76E. Next to it, we have the THC AD-10. And then on this back wall here, we have the 2 fans. And on this wall, we have the CNC port. And then kind of off camera that you can kind of see over here in the corner, we have the power input for the entire case. So generally what happens, we'll go through power input and distribution of that through the case. First, we have the power input over here in the bottom right of the screen. That power wire then feeds through this piece of webbing here, and then it splits into the 4 individual power wires and ground wires that feed the 4 different power supplies. From those power supplies, power is then split into the rest of the case to provide power to the different things. So the Z-axis and board power supply runs the 2 distribution blocks, and it runs the Z-axis. The Y2 axis powers the Y2 stepper driver, and then it also powers the 2 fans. And then we've got the Y1 axis, which powers this driver, and then we've got the X axis, which powers this driver. The Meza board, the 7i76E board, draws power through the circuit breakers. So the circuit breakers draw power from the distribution blocks, just to clean up the installation a little bit. Power goes from the distribution blocks to the circuit breaker, and then to the Meza board. And then the other circuit breaker provides power to the relay. The THC AD gets its power actually from the Meza board as well. So power goes from the Meza board to the THC AD, and then the THC AD receives input voltage from the optical isolator through the CNC port. For the CNC setup over here, there's a total of 6 wires that we're using. The top 2, pins number 1 and pin number 2, are the torch on wires. Those wires run into the first optical isolator here, which receives its signal from the 5-volt relay. Below that we have the arc divided voltage, which goes into the second optical isolator, and then the output of that optical isolator then runs to the THC AD. And then lastly, we have the arc OK signal. The yellow wire of the arc OK signal goes to the red distribution block, and then the green wire from the arc OK signal goes into the Meza 7i76E, and that's an input on the Meza board, which tells the Meza and therefore tells the CNC machine when an arc has been struck and when it's okay to begin movement. Fairly straightforward for that. Lastly, these 2 fans are always powered as soon as you hit the power switch on the side of the case. They're just 2 12-volt fans or 24-volt fans. One's facing in and then one's facing out, so that it gives a little bit of circular airflow in here for the case to keep the whole thing cool. In addition to that, the 4 power supplies have their own fans as well, and then the stepper drivers all have heat sinks on it. But this is to kind of give some better airflow throughout the case and to kind of pull out some of the hot air and to suck in some fresh air into the case itself. Kind of hard to see, I know. Feel free to reference the wiring diagram that you can get off the website for 99 cents. It's got everything in detail of all of the individual wiring steps, as well as breakdowns of the mesa board and of the Everlast pin connections. So if you need a little bit of help understanding this, or if you're more of a visual person like I am, you can go ahead and reference those wiring diagrams. That should help you out moving forward for this project. Anyways, we got the case done. So now we're going to put this back on the plasma cutter, and we're going to plug in the motors again, and we're going to give it a little test to see if it works. Everything works. The machine is back and operational. So now I'm just going to do some cleaning up. Got to clean up the whole shop out here, and then we'll move on to the next project. I am going to shoot another software video where I detail exactly how I made the software for the Linux CNC work and the step-by-step way that that has to go through to set up the configuration for that. I know that that video was not very good when I did it the first time, so I did figure out how to get a screen capture to work. So I'm going to run a screen capture, and then I'll dub over the audio. I should have that video coming out pretty soon, probably give me about a week to finish up the wiring diagram for this, and then to put up that video and get it posted for everybody. So stick around for that. I know I've got more videos coming out about the CNC machine. I'm going to keep going into the kind of the details on this. Probably going to build some more CNC machines too once I come up with some ideas of what I want to have and the different capabilities I need once I expand my shop a little bit. Anyways, thanks for watching, guys. I hope you all like that. Make sure to like, share, and subscribe. And drop a comment down below if you got any questions about this kind of stuff. I'm happy to help out as best as I can. So if you got any questions, feel free to put them down below in the comments, and I'll answer to the best of my abilities.